So last time we had just begun our section on numerical integration. That is, how can we find the integral of difficult things? So I'm going to start off with the integral of something fairly easy. We were looking at the midpoint rule. And so now I want to do an example of that. Okay, so we can see that we said that the integral from a to b of f of x dx will be approximated by taking the length of the interval and multiplying by the function at the midpoint. Okay, so here's an example, and I'll show you how this works. So I'm going to do something fairly reasonable that we can work with. Okay, this thing's going to act up. Okay. So we're going to do f of x is equal to x cubed. So I want to compute the integral from 0 to, let's say, 3 of f of x equal to, of the f of x is x cubed. Okay, so we know that's going to be 1/4 x to the 4th, evaluated between 0 and 3. So that's going to be 1/4. 3 cubed is 81, so we're going to get 81 over 4. Okay, so that's the true value. All right, so now if I draw f of x equal to x cubed from 0 to 3, I get something like this. And then here is my 3. Okay, so this is f of x equal to x cubed from 0 to 3. And I'm going to divide it into 4. And I'm going to say, for this example, we're going to let n equals 4. Okay, so that means all right, so I'm going to need this again. So I'm going to lasso this because I'm not drawing this thing again. Okay. All right, so for us, we let n equals 4. So that means our h, if you remember, h is b minus a over 4. And our interval is 0 to 3. So that is 3 minus 0 over 4. So each one of these intervals is 3/4. Okay, so now we have this interval here. So this is the first interval, second interval, third interval, and that does not actually look like it's really in the right place. I'm going to try to draw it again better in the right place. Okay. There we go. Okay, so that's where we're going to put the 3. All right, and so we're going to divide this into 4 intervals. Oh my gosh, my hand is really not good. Okay. All right, so we have divided this thing into 4 intervals. All right, so therefore, for this problem, for the midpoint rule, you have to take the midpoint of the interval. Okay, so that means we already know that this is going to be 3/4. This is 6/4. This is 9/4. And this is 12/4, which is 3. And this is 0. So by dividing my interval up into 4 equally spaced units, I get this distance from 0 to 3/4, from 3/4 to 3/6, I'm sorry, 6/4, etc. Okay, so now this is exactly the problem I want to solve here. So now what I need to do is, the problem says that the integral is to take the length of the interval, which is b minus a over n. We already know that that's 3/4. And now I'm going to use the midpoint. So now if I go to the midpoint of every interval, so let's go to the midpoint. Here's the midpoint. That midpoint is going to occur at 3/8. So this is 3/8. Okay, where's the next one going to occur? What's the next midpoint?
Would it be 6/8?
Actually, it's 9/8. But that was a good guess. You add them together and divide by 2. So this one will be 15/8. And that one's going to be 21/8. So those are the midpoints. So now if I go up to the midpoint and draw a line and fill it in, that is my area for that first piece. If I go up here and find the function value, and now this is the area of the next piece. I go up to the midpoint, go all the way over, draw and find the area of that block, and then go up to this midpoint, go all the way over, and then get the area. So now, as you can see, that is an approximation to the area using the midpoint rule. Okay. So the area, or the integral, let me just say the integral. The integral from 0 to 3 of f of x dx is going to be b minus a over n, which is 3/4. And then inside, I'm going to need f of 3/8 plus f of 9/8 plus f of 15/8 plus f of 21/8. Okay, so those are all the midpoints. We took the original interval that was from 0 to 3. We divided it into 4. So we got 0, 3. We got 3/4, 6/4, 9/4, and then we got the last value. okay? Then the midpoints. So if I take 0 plus 3 over 4, that's 3 over 4 divided by 2. My midpoint was 3 over 8. And then 3 over 4 plus 6 over 4 is 9 over 4 divided by 2 is 9 over 8. 6 and 9 is 15 over 8. And then this one was 21. Okay, so those are the midpoints. So I went up to the midpoint, drew a line, drew an area for the square. Okay, anybody have a question at this point? Does everybody know what I'm doing? Okay, let me look to see if anybody does not know what I'm doing. Okay. Well, I have a bunch of people who do not have their camera on, so I can't help you guys. Okay. All right, so now this is 3 over 4. Now, what was my function? Remember, f of x is here. So f of x is x cubed. All right, so that means I'm going to get 3 over 8 cubed plus 9 over 8 cubed plus 15 over 8 cubed plus 21 over 8 cubed. So that's 3 over 4. So 3 cubed is 27. And, oh man, my head hurts. 8 cubed is 8 times 8, which is 64 times 8. Let me see, 8 times 64. 512. 9 cubed is 729 over 512. 15 cubed is 3,375 over 512. And 21 cubed is 9,261 over 512. So let's move the 512 out. I think 512 is divisible by 3. No, it's not. It's not. So this now becomes 3, the denominator, pull the 512 out. So I get 2,048 times 27 plus 729 plus 3,375 plus 9,261. So let's see what we get. We get 27 plus 729 plus 3,375 plus 9,261. Really, 27 plus 729 plus 3,375 plus 9,261 equals. So now I get 3,000. So 3 times 13,392 divided by 2,048. And that turns out to be approximately 19.617. What was our actual answer? Oh, our actual answer was 81/4. So the true answer is 20.25. The integral from 0 to 3 of x cubed dx. Not bad, considering we only use four things. But notice how much error we had, guys. Look at all the error. Okay, so here we had so there are places where we had too much and places where we had too little, but it's not too bad of an approximation. Okay, now if I were to do it with n, as n gets bigger, the approximation gets better. So as n gets bigger, as n increases, the approximation approaches the true integral. Okay, so what did we just compute? We just did, and this should be an approximation. We just did an approximation for what we would call MN. So MN is B minus A over N times the sum I equal 1 to N of F of the midpoint of each interval. And that's called MN. So this value that we just computed right here, this for us is M4. Okay, any questions about that? Okay, this is going to take some practice. All right, so that is the midpoint rule. I think I called that A, called it 1. Okay. All right, let's go with 2. What in the world is going on? Thank you. Okay, trapezoidal rule. All right, does anybody know the area of a trapezoid? What is the area of a trapezoid? Anybody know or remember?
It is half times height times base 1 plus base 2.
That is exactly right. Okay. So if we have a trapezoid, I'm going to try to draw a trapezoid. Okay, so here's a trapezoid. All right, it assumes that the two sides are equidistant from each other, the top and the bottom. So I can have a height, H here. So this is my height. This is base 1. This is base 2. So the area of the trapezoid is 1/2 H times base 1 plus base 2. Okay, so now I'm going to take my picture that I had before. Actually, I'm just going to take a general picture right now. And let's suppose here's my interval A and B. And I have a function f that goes through like this. So this function is my f of x. And, no, I don't want that red. I want that gray. I want to try to find the area under the curve of f between A and B. Now, we've already done this with the midpoint rule, and we already know that the midpoint rule is not the best method to use that for. Okay, so let's say I'm going to have one interval. So we have one interval. So n is equal to 1. So h is just b minus a over 1. So this distance right here is h. So to me, I'm going to equate that with the height. And I'm going to let this side be base 1. And I'm going to let this side be base 2. And I am going to draw a line between these two as such. And now I have a trapezoid. Okay, so now I have a trapezoid. So I hope you can see it. Turn sideways to see it. All right. If you turn sideways to see it, then here's the height. Oh, actually, I got them out of order. Got them out of order. Let me put them in order. This should be base. This would be base. I'll change this. Make this base. So I'll make this base 1 and this base 2. So now they are in order. Okay, so if you turn sideways, I have a trapezoid, okay, where this side is the top, this side is the bottom, here's the height, and here's the other side. Okay, so there's my trapezoid. So now the area of my trapezoid is 1/2 the height times B1 plus B2. But notice this height, B1, is just f of A. And this height, B2, is just f of B. So now I get the area of that piece is 1/2 H times f at A plus f of B. All right. And I'm going to call that approximation T1 because I'm using the trapezoidal rule, but I only let n be 1. Okay. I let n be 1. Okay. Now we're going to take the same picture. I don't want that picture, so I'm not going to mess this up. Okay. Suppose we let n be 2. So if I took this picture and redrew it, and I'm going to have a bunch of, I'm going to do the same thing. And this time I'm going to let n be 2. So now I have 2 intervals. So h is b minus a over 2. Okay. So now I'm going to do the same thing as I did before. Here is, oh gosh, A to B. And this time I'm splitting it up and I have a middle point here. So now I'm going to call this point X0. That's my A. I have 2 intervals, so this is going to be X2. That's my B, and I'm going to have 1 in between. That'll be X1. Now I'm going to draw 2 trapezoids. So here's the first trapezoid. And then here's the second trapezoid. So notice I have 2 trapezoids now. So now when I go to compute this area, I'm going to call this thing T2. So T2 is going to be the area of the first trapezoid. So the area of the first trapezoid is going to be 1/2 H times F at X0 plus F at X1. And the area of the second trapezoid is going to be 1/2 H F at X1 plus F at X2. So now T2 turns out to be H over 2. Now I'm going to get F of X0, X0 plus, look at here, I have 2 of these, F of X1 and a F of X1. So I get 2 F of X1 plus F of X2. So now this is T2. So let's go back and highlight T1. And now let's highlight T2. Okay, so I can keep doing this. So the formula for the trapezoidal rule for Tn, so let's just say. So if we divide the interval A to B into n subintervals, where H is B minus A over N, then Tn, which is the nth approximation, is going to be H over 2, F of the first one, F of the first endpoint, that's A, plus 2 times F of the X1, plus 2 times F of X2, up to all the ones in the middle, 2 times F of Xn minus 1, plus 1 times the last one. That's my formula. So this is my formula Tn. And Tn is again an approximation to the integral from A to B. All right. Questions before I move forward? Okay, can anybody explain to me, let's go back. Go back. Explain to me this example with the midpoint rule. Somebody want to explain it to me, please?
Isn't it basically the midpoint rule where we try to approximate the area underneath the curve?
That's right. Okay, so for this particular example, I let n be 4. I found the midpoint of the interval. I went up, found the height, made a rectangle, took the area of each rectangle and added them all together. Okay,
I have a question.
yes.
Would we always make it n equals 4?
No. N can be whatever you want it to be, and the problem will tell you. It will tell you what n is. Okay, so the problem is going to tell you what n is, how many to use. All right, so I just said for this example, I let n be 4. But in general, it might say find T5 or T6 or T whatever. Okay, so I want to go back to my example. The integral from 0 to 3 of x cubed dx. We already know that that is 81 over 4, or 20.25 is the exact answer. And we got the answer with the midpoint rule, right? So now we're going to use the trapezoidal rule. With n equals 4. Okay. So we already know that we're going to divide the interval . So this is going to be x0 was 0, x1 was 3/4, x2 was 6/4, x3 was 9/4, and x4 is 12/4 or 3. Okay. So now we don't need midpoints because we're not doing the midpoint rule. All right, we're not doing the midpoint rule, we're doing the trapezoidal rule. So the trapezoidal rule says use the endpoint, use the actual grid points. So T4 is going to be B minus A over 2, well, H over 2. What did I write up here? Oh, good, okay. H over 2. I'm going to take f of the x0. I'm going to need 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3, and then 1 times the last one. So this is going to be h, remember, was 3/4 divided by 2. This is going to be f of 0 plus 2 times f of 3/4 plus 2 times f of 6/4 plus 2 times f of 9/4 plus f of 3 or 12/4. Now here's what's cool, guys. We already computed half this stuff already. So if you remember up here, let me grab this for a moment. Where's my camera? Mess up my other thing. Okay, so we've already computed from before. well, we didn't compute f of 0, but f of 0 is 0 cubed, and that's 0. We did f of, oh, actually we didn't. We did the midpoints. Ah, can't use those. Can't use those. So we now need to do our own. So we need f of 3/4, which is 27 over 64. We need f of 6/4, 36 times 6 is 216, I'm guessing. Yep. So this is 216 over 64. F of 9/4, 9 cubed. We did 9 cubed. 9 cubed was 729. And then f of 12 over 4. $1,728 over 64. Okay. All righty. So now this becomes 3/8, 0 plus 2 times 27 over 64 plus 2 times 216 over 64 plus 2 times 729 over 64 plus 1 times 1728 over 64. Okay, so let's see what we get. So this is 3/8 times 27 over 32 plus 216 over 32 plus 729 over 32 plus 864 over 32 plus 729 plus 216 plus 27. So I get 3 times 1,836 divided by 8 times 32. $256. So when you take that number 3 times, 3 times 1,836 and divide it by 256, you get 21.516. So that is even closer to, that kind of overestimated it. The other one underestimated it. This one overestimates. Why do you think it overestimates? Well, let's look at the picture. Okay, so for this one, this is our last, last thing. Okay, so why do you think this overestimates? Well, because all of our trapezoidal rule is going to put trapezoids like this. So this one overestimates our value. Okay. Still not bad though. Okay. So there's one more rule. I am not going to derive it because deriving it is a nightmare. All right. But there's one more rule called Simpson's rule. Oh, one of the things I forgot to do is to do the errors. Let me go back. So let's just do the errors. Okay, did I do the error? You know what? I just taught a class where I did errors, so I don't think I did the error. Okay, so let's look at this. So let's look at the two we have. So we have the midpoint. So we have the true integral of x cubed dx. And that turned out to be, so that's the true value. Okay, so we had M4, and M4, the approximation gave us 19.617. Okay, so therefore the error in M4 is the absolute value of the true value minus the approximated value. All right. So that's 20.25 minus 19.617. Whoa. Wrong. 20.25 minus 19.617 is 0.633. So that's the error. Now the relative error is to take the true error, which is 0.633, and then divide by the true value. So the true value is 20.25, and then multiply by 100. That's going to give you a percent. So if I take that and divide by 20.25, multiply by 100, so this is only 3.13% error. That's really small. Okay, that's not bad at all. Any questions about that? Okay, so the error is take the absolute value of y true minus y approximate. Okay, and then the relative error is to take the absolute value of y true minus y approximate and divide by y true. Okay, and multiply by 100. All right, any questions about that? All right, so let's see what we did with the trapezoidal rule. So with the trapezoidal rule with T4, we got 21.516. So therefore, the error in T4 is the absolute value of 20.25 minus 21.516. And I'm trying to think. Actually, that's going to be worse. Generally, the trapezoidal rule is better. But for this problem, it is not. So that is equal to 1.266. So therefore, the relative error is equal to 1.266 divided by 20.25 times 100. So that's 6.25%. Usually the trapezoidal rule is better. I don't, this just the way this problem came out, that it's like that. Okay, any questions? Okay. The last method, there's a left-handed rule, a right-handed rule. We're not going to worry about all those. We're just going to go to Simpson's rule. Okay, so Simpson's rule is approximated by actually allowing a quadratic to approximate, to figure out or approximate the function and then integrating that. So Simpson's rule is as follows. So again, so first off, n has to be even. Okay, so n has to be even. And then h again is still b minus a over n. But now Simpson's rule is h over 6. You do f of the first one plus 4 times f of the next one plus 2 times f of the next one plus 4 times f of the next one. So all the odd ones you multiply by 4 and all the even ones you multiply by 2. That's wrong. No, that's right. 4 times f of x n minus 1 and then f of the last one. Okay. So now we did calculate these f values already, so let's use them. So we already calculated these, so we're going to need them again. Okay. All right, so for Simpson's rule S4, again, h, we're still on the interval 0, 3. So h is still 3 over 4. But now we get 3 over 4. This time it's divided by 6. So I'm going to get f of 0, which is 0, plus 4 times f of 3/4. So that's 27 over 64. Plus 2 times f of 6/4, which is 216 over 64. Plus 4 times the next one, which is 729 over 64. Plus the last one just as it is. Okay. So I now get 1/8, 3/4 divided by 6 is 1/8. And so now I'm going to get 4 times 27 plus 2 times 216 plus 4 times 729 plus 1728 equals 5184 divided by 64. What did I do wrong? This is supposed to be over 3. It's not over 6, it's over 3. Now let's try that again. 5184 I got 20.25. Look at that. Pretty exact for a cubic. I don't think it should be that exact though. Let me just double check my answer because that's pretty exact. That's the answer. So as you can see, Simpson's rule for this particular problem has no error. Okay, any questions, guys, on how to do this? Let's do minus x squared. That'll be better. Okay, so we're going to try all 3 rules and we're going to let n equal 4. Okay. Well, actually, we've already done n equals 4. Let's do n equals 6. Let's just do trapezoidal rule and Simpson's rule with n equals 6. Okay, so trapezoidal rule. Okay, and I'm doing this in the middle of my exam, and I don't have a calculator. Oh my, how am I going to solve this problem? Okay, what do you think we're going to do? How do you think we're going to handle this problem? Hello?
Are we gonna set it up first?
Okay, so how do we set it up? What's h? What is h? Okay, somebody put something in the chat. Okay, yes, Victor. For a few minutes. Okay, what's h? Come on, guys, what's h? H is not changed from the very beginning of yesterday's lecture to today. What is h?
Would it be 4 divided by 6?
Okay, good. It's b minus a over n. So therefore, it's going to be 4 minus 0 over 6, which is 2/3. Okay. So now I have 0 to, actually, let me do one where it's not, doesn't start at 0. Let's do one where it starts somewhere else. So it's going to be b minus 1, 4 minus 1 over 6. So it's going to be 3 over 6. So it'll be a half. Okay. Just so you guys can see that it doesn't always have to start at 0. Okay, so this is x0, x1 is going to be a half, is 3 halves. X2 is 2, x3 is 5 halves. X4 is 3, x5 is 7 halves, and x6 is 4. Okay, everybody see that now? Okay. So T6 is going to be b minus a, which is a half, over 2. So now I get f of the first thing. So that's going to be e to the negative 1 plus 2 times f of the second thing, which will be e to the negative 3 halves squared, plus 2 times e to the negative 4, plus 2 times e to the negative 5 halves squared, plus 2 times e to the negative 9, plus 2 times e to the negative 7 halves squared, plus e to the negative 16. Okay, everybody see that? So T6 is going to be 1 over 4. I'm going to have e to the negative 1 plus 2 times, I'm going to put all this in parentheses because I'm tired of writing the 2's, e to the negative 9/4 plus e to the negative 4 plus e to the negative 25/4 plus e to the negative 9 plus e to the negative 49/4 plus e to the negative 16 Oh, I forgot. I got to end this right here because everything inside of here is multiplied by 2. And then e to the negative 16. All right, does everybody see that answer? That answer will get you 10 points on the test. Okay. Now, if you do have a calculator, and I'll let you, and you won't have calculators on the final. So on this test, I have to decide if I want to let you use calculators or not. We generally just don't use calculators from Calc 1, 2, and 3, but that answer right there, 10 points on the test. Okay, so now if I ask you to use Simpson's rule, now we could figure this out. I could calculate that. I don't know how to do it, writing it out, but okay, so Simpson's rule would be 1/2 divided by 3. I would have e to the negative 1 plus 4 times e to the negative 9/4 plus 2 times e to the negative 4 plus 4 times e to the negative 25/4 plus 2 times e to the negative 9 plus 4 times e to the negative 49/4 plus e to the negative 16. And that answer would get me another 10 points on the test. Notice we cannot compute that integral. Okay, any questions? So this is numerical integration. Okay, improper integrals.